And we're back here again at the 1969 Arkansas State Basketball Championship. The score is 154 to 152 and running into the final seconds of this nail-biter. The Dingbats are ahead of the Cuddle Puffs with only 20 seconds left in the game.
Lau Ming is running down the court for the Cuddle Puffs. The ball is passed to him 20 feet away in 0.5 seconds, having a velocity of 40 meters per second. After catching the ball, he accelerates down the court at 3 meters per second.
He would continuously travel because of inertia, but he stopped himself. As a matter of fact, that's called Newton's first law. Yao Ming also weighs 55 kilograms because he's thick. Since we know his weight and his acceleration, we can find his force by simply multiplying his mass and his acceleration. So 55 times 3 is 165 newtons of force. We use Newton's second law, which is force times mass equals acceleration.
Lau Ming shoots the ball with a vertical velocity on the ball of 12 meters per second and a horizontal velocity of 9 meters per second. This then causes the ball to have a combined velocity of 15 meters per second. And the shot is good. The Cuddle Puffs win the game.
Another important factor with Lau's amazing performance is his ability to grip the court. This has to do with his shoes, which were made to grip the court. His coefficient of friction would be modeled as mu equals friction divided by force normal. When a force acts upon a certain object, the speed and position that a certain object could alter. We know that the speed and position of an object changes. To find out what was not changed in the situation, we use the law of conservation of energy. The law of conservation of energy is when a force is exerted on objects, energy changes from one form to another. The total amount of energy could always be the same in this.
As the ball was being shot and before it left Lau's hand, there was potential elastic energy. Right after the ball was shot, there was all kinetic energy and no potential energy. As the ball rose, reaching its peak, the kinetic energy slowly turned into potential energy. At the top, there was all potential energy. As the ball was going downward, the potential energy slowly changed back into kinetic energy. After the ball went through the hoop and right before it was caught, there was all kinetic energy. After the ball was caught, there was all potential energy.
Work is a transfer of energy. Work is force multiplied by distance. For example, if a ball had 25 newtons of force applied and was thrown 15 meters, then there would be 250 joules of work on the ball. Hey guys, I'm the new kid.